And you have all been muted. If you were like to ask a question, we're going to use the raise hand function. If you go to participants and activate that, there's a place on the sort of the bottom left where you can raise your hand if you have a question, and then our speaker Gabriela García would be able to sort of call on you to ask questions. I wanted to just take this moment to thank the Hoke Cunningham families for supporting this series, and I thank you all for joining us. It's nice we can continue virtually, and I see we have a really nice turnout today. Before I introduce Gabriela Garcia, I'd like to see if there are any announcements.
Hello, I have an announcement. This is Sarah Gomez from Environmental Studies. My announcement is the same one I made last week. We have a photo contest. The deadline is coming up next week. First prize is $150, second prize is $100, and third prize is $50. So if you have any nice environmental pictures, maybe from a spring break, if you went somewhere, you could use those. It's all digital, so if you're a Tufts undergrad, go ahead and submit your pictures. I will post a link with the guidelines on the chat box, so if you're interested, click it and follow the instructions.
Are there any other announcements? If you have one, raise your hand. Okay, I hope you are all safe and well and healthy and managing in these times of more isolation than others. It's really great that we can come together and listen to Gabriela Garcia. I'm super pleased to introduce Gabriela. I've known her for about 4 years now. She is a graduate student in the biology department. In fact, she's been working with me since she arrived at Tufts. She's in her 4th year. Gabriela, when she interviewed, she came to my office and said, "I'd really like to do something related to climate and the tropics." And we sort of started exploring about topics that might be really interesting to do. I had been working climate impacts on tea, and I thought, wouldn't it be fun to sort of think about coffee as a study system? Coffee is grown in Central America, and I actually speak Spanish, so I thought this could be fun. Gabriela speaks Spanish. We could come up with a really nice project, and it has not disappointed. Gabriela is going to tell you a little bit about her PhD work and a couple things that are really noteworthy about it. She's really working hard to integrate the social and the natural in her research, thinking about ways that we don't just study the coffee plant or the rainforest or any other system in isolation. We think about how the people who rely on that system are impacted by any kinds of threats, variation, fluctuations in the environment. And she's done a beautiful job at sort of weaving together a perspective that takes into account the relationships that she's built with farmers and other sort of stakeholders in the system, as well as the plants themselves. So you're going to get a little bit of a taste of coffee in this talk, and I'm going to turn over the floor to you, Gabriela. Thank you so much for agreeing to give a Hoke Cunningham lecture.
Thank you so much, Colin. Can you hear me okay? Great. Really excited to share some of the work that we've been doing over the past 3 or 4 years or so. I'm really excited to see so many people have tuned in. I appreciate you taking the time. And I'm joining you from the rolling coffee hills of Medford. Just kidding, but with the virtual background, we can pretend. So the title of my talk today is a socio-ecological approach to sustainable coffee yields and farmer livelihoods. Let's see. So first, let's just introduce the coffee system. It's really important globally. It, of course, not only keeps us functioning, but fuels a massive global economy, right? So it has this really important economic role in the world. It's estimated at about $19 billion. It's one of the most valuable agricultural commodity exports for the past several decades. And what's interesting about it is that it's supported and it supports the livelihoods of millions of small-scale farmers, and those are largely in developing countries around the world, right? Particularly in the tropics. And so it's exciting from another point of view because it's grown in highly biodiverse ecosystems or biomes. So it's often grown at fairly high altitudes in the tropics, where there's sometimes cloud forests that feature birds like this one, the resplendent quetzal. It's the national bird of Ecuador, I believe. And this is what a coffee plant looks like. So many of us were fueled by coffee, but we don't necessarily know exactly what the plant looks like or who grows it, right? So here it is. And those little berries that, I'm not sure if people can see my mouse. Could someone maybe in the chat let me know? But these berries, you see it? Great.
Yes.
Okay, so these berries here are the coffee cherries, and within each of those, there's going to be 2 beans, which will eventually be roasted and ground and brewed. And it's a sort of small bush. It's a perennial bush, which means that it reproduces every year. And this is the plant that we rely on for our energies in the morning, many of us. And so I'm working specifically in Costa Rica with farmers there. Cultivation in Costa Rica began over 200 years ago. It was brought over from sort of the lowlands of Africa. And it's mostly Coffea arabica, which is one of the species, and that's the more higher quality producing species of coffee. The other one, Robusta, is used more in like instant coffee brews and things like that. So coffee production in Costa Rica was really critical to the whole economic development of the country. It funded the National Railroad, among the National Theater, so all sorts of things. And so it still has this really important cultural value, though its economic value to the country has declined a bit as Costa Rica becomes sort of more technologically advanced. It's about 2.5% of the GDP right now. And the area that I work in specifically is right here in this little box, so sort of just south of San Jose, going into that mountain there, the Continental Divide. And there it's higher altitude. It's considered the highest quality coffee growing region in Costa Rica. Up there, it's not urban, so it's very rural. So there are pretty few livelihood alternatives. Coffee is really the main driver of the economy in this area. And it's also situated within a forest reserve. And so you can see how farm decisions that farmers make in terms of how they're going to manage their farm have a lot of implications for the surrounding ecosystem as well. So first, before I dive into some of our research questions, I just wanted to get everyone familiar with this really incredible coffee community that we've been working with. So this is data that was pooled from about 29 farmer participants so far, and we've interviewed them. And so the average among them farm size is about 6.5 hectares. So it's considered small scale if it's less than about 10 hectares. And often about half of that is planted with coffee. Now the other half might be shared with another crop, as you can see here. About 70% of farmers grow something like avocados or maybe beans mixed in. Many people mix in plantains. But a lot of times what's not planted with coffee is just preserved forest as well. The average elevation of this region is 1,732 meters above sea level. So that's pretty high in terms of coffee producing areas worldwide. Most people have gone through some high school, most of the coffee farmers, and they skew towards sort of the older side. So they have about 25 years of coffee farming experience, right? Largely dependent on coffee for their income, as I mentioned, it's about 70%. Up here we have a farmer, Armando, who in addition to having a really amazing coffee farm, really beautiful and biodiverse coffee farm, he also grows avocados and runs the local pizza shop. So you can see ways that people are sort of innovating and mixing in other ways to get their income. But down here we have Miguel, who has been really fundamental in developing this project and its execution. And he does live basically 100% from coffee. He had a small chicken producing business, but has left that to his son. So this is the people that we work with. And they're all associates or former associates of the local coffee cooperative. So that's where all the farmers sell, they bring their beans there and they sell that to the cooperative, which is just sort of an organization run and operated by fellow coffee farmers. So then they can sort of collectively bargain for deals, international deals. And so we talked to the farmers and asked them what are some of the threats that they're facing. So we know from the literature and from news that there are some threats that they're facing. And so when we ask them, there's a lot of overlap between what we read about and what they identify as the biggest threats. So the one that most farmers identified was coffee prices. So as an agricultural commodity crop, it's sort of run by stocks and things like that. So it's very hard to predict what the value of your coffee will be in any given year. And so this is just a graphic here that shows time on the x-axis in dollars per pound that farmers receive on average on the y-axis, and about $1 per pound is what's considered just enough to sort of even live off of coffee, to sort of break even, right? And so you can see that it's dipped well below that on numerous occasions. So this is clearly one of the main threats. Also the increasing cost of inputs. So that could be fertilizer, it could be pesticides or fungicides, whatever they have to sort of invest in their farm. Those prices keep going up, whereas the price of coffee sort of shoots all over the place, right? Climate change is, of course, on the mind of many farmers. And related to that, there's an increase in pest pressure as well. So here, this is an image of a coffee leaf that's been attacked or infested by the coffee leaf rust. So all of these little patches of spores, and they attack the leaf, so that decreases their photosynthetic capacity, and just sort of can really damage the plant health for future production. And this is something that these farmers didn't face about 10, 15 years ago. So that relates right to the cost of input. So everything sort of works together here to create this sort of dire situation for coffee farmers. Zooming in on the climate change perspective, so we asked farmers what were the climate changes that they've already experienced. About 50% identified that it was getting warmer in this region. And a third of farmers that were asked pointed to increasing variability in the precipitation. So this is a region where it has it typically had a very well pronounced dry season between like November and March, February. And that's really compatible with what coffee needs for its production. And then it had a well-defined rainy season where it would rain at about noon, basically like clockwork every day. And that spans from like May through October or so. But now the summers are getting warmer, but they're also maybe have some rain during them. And then the winters or that rainy season sometimes get drier, or the precipitation is sort of concentrated in these big events, right? So that makes it really hard for farmers. And so when we asked them, how has that affected their coffee production? The majority over here pointed to negative impacts like increasing disease, as I mentioned, problems with the flowering. So the flowering won't sort of stick, as they say. So it'll flower, but then abort many of those flowers. And yield stability, which I'm going to talk about a lot more later. But some pointed to some positive impacts of these climate changes, and those are especially related to the altitude. So as I mentioned, this is a pretty high altitude region. Coffee tends to sort of, its growth is hindered above, or when temperatures drop. So about like 1900 meters or so would be considered the limit of what it can grow at. And this region spans from about 1500 to 2000. So it's right there at sort of the upper limit. But as temperatures rise, then people that have farms at the highest upper limit of that, they're starting to benefit, right? And that limit is sort of shifting upwards as well in terms of elevation. So farmers there have experienced some positive impacts, but of course, you can see that there's no sort of unanimous consensus so far on any of these questions, and that some farmers have identified no impact on coffee. Okay, so given this sort of scenario and situation, what can we do then to make farmers more resilient to disturbances, whether those are droughts or intense rainstorms, right? So this is what's driving our questioning. And there's many different frameworks to address farmer resilience, but one that I think is especially appropriate is this concept of socio-ecological resilience developed by this guy, Binet. And so it's not super important to comprehend this whole graphic here, but what I want to point out to you is that he argues that stability is really important to building these sets of capacities critical to withstanding change or disturbances. So if you have stability in terms of your income or your yield, then you're going to be better prepared to absorb an unexpected change as well. The problem is that it's pretty hard to achieve stability because coffee is what's called alternate bearing. And all that means is that a year of high production is often followed by a year of low production. And so this is a graph that I made with data from the cooperative of just a farmer. And you can see that there are these huge spikes, which probably reflect something more like he expanded his farm or something, but it's still really effective at capturing that a high year tends to be followed by a low year. So you can imagine if this correlates really closely to his income is all over the place between years. So that has a lot of implications for farmer livelihoods and is thus a barrier to resilience. Right? And it's not just sort of an isolated problem. So it can be a synchronized event where lots of farms are experiencing fluctuations that are similar in magnitude. And so it's been argued that a weak year in Brazil's biennial cycle has implications for the global coffee prices that all farmers around the world experience. So in 2011, it was a really terrible year for Brazil's coffee production, which meant it was a great year for everybody else in terms of pricing. And about 63% of the 30 interviewees that we've interviewed so far have pointed to sort of personal experience with this alternate bearing and that it's been a problem for them. And so in today's talk, I'm going to go over some of the experiments and results of, to answer these questions. So to put it simply, we were interested in why does coffee fluctuate in yield? And I'll talk just briefly about a theory that we're applying to understand that. And then I'll transition into what farmers can do about it. So sort of what is their agency to mitigate these fluctuations and to promote stability to their farms and their livelihoods. And then we're going to zoom out even further. So we're looking at sort of plant level, and then within a farm, what can they do? And then even between farms. So some things that are more or less out of their control, like the elevation of their farm. They can't shift it around. So how does farm altitude then interplay with both sort of the plant level functioning of these fluctuations and the role of management to promote stability? Okay, so the theory that we're applying here is known as the resource budget model. And basically it's an equation, and it was developed to explain this phenomenon of these fluctuations in reproduction or seed production in plants. And so it was developed for this phenomenon of masting, which is common in a number of forest trees like oaks, where they'll produce all in synchrony a huge seed load in 1 year, and then they'll go several years without any, right? And then all produce again. And so there's different hypotheses about what could be driving that. It could be weather related, or perhaps resources available in the soil tend to fluctuate. But this model posits that actually it could develop, these patterns could develop if a plant just overinvests its resources in fruit load, and it takes a number of years for it to build them back up, right? So we were intrigued by this because this model can also be what's called parameterized, or sort of adjusted to fit with this biennial cycle. And so we were wondering, okay, so if it's a trade-off in resources, that it's over-investing in the fruit load, do we see that dynamic playing out in coffee? So is coffee over-investing resources in fruit load at the cost of future production, which would lead into a cycle of biennial bearing or alternate bearing? So that means that our specific question then was, what role do these resource trade-offs play in coffee's alternate bearing? And so I'm just going to go quickly through a couple of areas where we looked for trade-offs in the system. So we expected that if this is a little doodle basically that I drew, but here's a vertical stem of a coffee bush, and you see a lateral branch here. So the lateral branches are the site of reproduction. At these reproductive nodes, they'll have some berries. And our hypothesis is that if they have more berries at these nodes, then they're going to grow and extend their new vegetative tissue or plant tissue less. So that's this first one. Are they gonna, if they have more fruits down here, will they have less nodes develop? And we're interested in that because the nodes or the branch portion that they extend while they're maturing their fruits is going to be the site of reproduction the following year. So if they don't grow very much, then they probably won't reproduce very much. We also looked at how having a greater number of these cherries affected the bean quality that's within the cherry, assuming that if there was more cherries, there would be smaller beans inside. And we explored whether if they had more this year, right, whether that does in fact play into the following year of if they have more in one year, then they're going to produce less fruits in the following year. So the plant cycle of coffee, it's a sort of 1 year cycle. So they flower in about March or April in this region. And then those flowers are pollinated and they become these little, what's called sort of pinhead cherries. And that's when we do the manipulation I'm going to talk about in a minute. For the next several months, they fill up those berries and they grow at the same time. So this is a branch, and you can see it's developing all these new nodes, and it's filling these out, and they're starting to ripen from green to red. And in December, when they look so beautiful and juicy like this, we harvest them. And it starts again the following year. Okay. So for this experiment, it was a manipulative experiment, which we did on 3 rainforest certified farms. And so what I mean by manipulative experiment is that we were in control of the variables. So on a number of plants, we marked them and assigned them to the different treatments. And here's a branch that has 3 reproductive nodes that have just, these fruits are fresh. So this is probably about May. On the control plants, we didn't do anything. But on the 1/3 removal plants, this 33% fruit removed, we removed all the fruits that were at one of those nodes. And on the 66% or 2/3 removal, we removed all the fruits from 2 out of every 3 nodes. And we did that at the whole plant level for a number of plants, right? So in this way, we're able to directly manipulate sort of the number of fruits that they have left to invest in over the next several months. And again, our hypothesis was that the plants with the most fruits would grow less, and the ones with the least fruits or most thinned would grow the most. And that's what we found. So this is from data from 2018, and we found that when we removed 1/3 of the fruits available, or the fruits remaining, then the branches extended significantly more compared to the controls. And when we removed 2/3 of the fruits, they were then grew over the next several months much more than both the 1/3 and the control. Right? So this is support of a trade-off with growth and reproduction. And when we looked at bean quality, so we harvested the beans and they were processed by the local cooperative, and we weighed them, and we also measured the diameter, but here I've just included the weight. And these all look pretty close to each other, but there's thousands of data points. So the statistics are able to detect pretty small, but statistically significant differences. And so we see that when we thinned the plants, they also made heavier beans. And so bean weight and bean width are, or basically bean size, is a measure of bean quality. That's really important to the farmers. So we see that when they had more fruits, they made lower quality beans. And when we looked into the following year, how many fruits did they initiate, we see again a significant effect, particularly when we removed 2/3 of the fruits. That means that next year they produced way more fruits on each node than they did if they had a full fruit load in the prior year. Okay, so far we have demonstrated that coffee does exhibit these resource trade-offs associated with high fruit load, and we found support for this ecological theory, the resource budget model. Okay, but what if we zoom in a little bit and try to think about which resource is it? So we hypothesized that nitrogen might be a candidate driving that plays a big role in this resource depletion and alternate bearing. So coffee cherries are pretty rich in nitrogen. Caffeine is a compound that's heavy in nitrogen. And nitrogen is also not in abundant supply, often in tropical soils, particularly ones that have been farmed for a long time. Shout out to Leslie Spencer, who ran a lot of this analysis for me. And here's Colin and I. We've harvested the berries, and so we brought them to the co-op to be processed. And this is a picture of what it looks like when the beans are being sun-dried and processed outside. So they're white before we roast them, and that's the little bean that's inside each of those red cherries. Okay, so we were looking at nitrogen. Is nitrogen depleted by high fruit load? This was in a follow-up experiment to the one that I just showed you. So again, we thinned, but this time we just did sort of like heavily thinned and unthinned controls. And our hypothesis or expectation was that plants that had less fruits or that were more thinned would then have a greater concentration of nitrogen at the end of the season because they didn't invest it in that fruit load. Right? And again, we found support for that. So this is pretty fresh data and we're really excited about it. So we saw that when we did thin them, plants had a higher concentration of nitrogen left in their leaves and in their stems, right? And so now we're exploring whether that difference is going to persist or how quickly the plants that did have a fruit load might be able to sort of catch up. So we're excited to follow this experiment into this season, this year. Okay, so takeaways so far. Now we've also added that nitrogen is depleted through high fruit load. Now, if we zoom out from that sort of plant and leaf level analysis, we start to think about, okay, so what can farmers do about it? How does their decision making, especially around management practices, mitigate or exaggerate these trade-offs? Shout out to Madeline Bondi, who helped with a lot of this data collection. So when farmers have their little baby plants, this is called an almacigal, then they have a decision to make. Are they going to cultivate it in a sun-grown monoculture? So this is sort of following like the Green Revolution, just like intensified, efficient agriculture. Or are they going to opt for the more traditional, but potentially low-yielding alternative of a more diversified shade cover system? So here you can see some coffee bushes. This is a banana plant covering it. Looks like maybe avocado, or it could be a fruit tree there. Also the nitrogen fixing erythrina or Perot is their common choice there as well. So they have to decide sun or shade, and they also have to decide how much fertilizer they're going to use. So some people use relatively low fertilizer, and some people really invest in fertilizer and hope to see a gain on that, right? So these are the decisions that we focused on. And so we set up an experiment where we had all possible combinations of them, or it's called a factorial experiment. So we had one plot that was high fertilization with a shade canopy over the plants, which is sort of the current recommendation from ICAFE, or the National sort of Coffee Institute of Costa Rica. The variation on that is a shaded farm, but with low fertilization. So this would be a traditional, it's the environmental ideal. It's like low chemical plus it's biodiverse, but low yielding alternative. And then there's this more intensified, high fertilization, sun-grown monoculture, so high chemicals, and also just a sun-exposed monoculture. And so this was heavily promoted during sort of the 70s and the decades to follow as the new norm. And then the variation on that is a low fertilizer in the sun, which would just be sort of a suboptimal. Perhaps you have a sun farm, sun monoculture, but you don't have enough money for the fertilizer that you normally do. So this would be a variation on that. So we were interested in how these different alternative management strategies might influence these resource trade-offs and alternate bearing. Also, these are all configurations that actually exist in the landscape. So since this is the high fertilization and shade is the current recommendation, but people were told to do the sun grown for many years. So now you see really a wide mix of all of these across the farms in this landscape. So to ask this question, we were interested in how these management strategies might influence the magnitude of the trade-off. So to do that, we have this alternate bearing index, it's called, and it's just the absolute value of the difference in yield over their sum. But basically, it just creates this index from 0, which would be less alternate bearing, so very flat, stable yields across time, would be closer to 0, and closer to 1 would be high variability between years. Based on the resource budget model, we thought that the high fertilizer and sun treatment would have the most severe alternate bearing. So the highest alternate bearing index, which means most variable, right? And we thought that because basically when you plug in some numbers to this model, it suggests that actually having more resources available might just cause the plant to overinvest even more rather than allowing it to sort of stabilize and meet all of its needs. We thought that high shade, the shade would limit fruit load a bit, so that would promote stability, and that the lowest would be low fertilizer and shaded. So it would be very stable yields, but probably not very high yielding. Okay, so we're just looking at that variability over time for now. And what we found was pretty closely aligned with our hypotheses. So we did see the greatest variability between the 2018 and 2019 harvest when we looked at the high fertilizer sun plot. It was mitigated or lower variability between years when we looked at the high fertilizer and shade. And in both of our low fertilizer treatment, both the sun and the shade, we saw stable or more stable yields. But again, farmers want high stable yields, so probably this isn't the best alternative. So far it looks like shade is a promising candidate for a mitigating factor, particularly under high fertilizer. So trade-offs are greatest under the intensified fertilizer regime, and shade mitigates it. This is that nitrogen fixing plant I was telling you about, and more banana over these coffee bushes. Okay, so now we've looked at sort of plant level, leaf level, farm level, and now we're zooming out even further to sort of between farm. So it's a beautiful landscape in this area. You can see it's a valley here, and then coffee. This is all coffee going all up the mountain. Over here, a bunch of coffee with banana, coffee right up here. So we're interested in how a farm's location on these slopes might influence alternate bearing and the effect of shade on alternate bearing. This is sort of our freshest analysis so far. So I'm not going to go too much into it, but I just wanted to give you a sense of some of the questions that we're asking and hoping to answer with this experiment. Shout out to my wife, Gabriela García, and Angie Navarro, who's a local field assistant, and they were really critical in developing this part of our experiment. Okay, so again, our question is, does farm altitude interact with alternate bearing and shade? Here's a map of that region. So you can see this is the town that was in this picture. Well, you actually can't see it, but so it's a valley. So this is sort of the valley area right in here. And those are going to be our low altitude farms. So we had 11 farms per altitude, low, medium, and high. So the low ones are sort of in the center of this valley. As we move up in elevation, we see our mid altitude farms. And then at sort of the extremes, we have our highest altitude farms. And those are going to be above 1,800 meters. And so we were interested in, we followed 10 plants per farm. So far we have 2 full seasons, so 2018 and all of 2019. And we were looking at how farm altitude, how the shade level, and then we measured yield as well. And so if we just look at the variability between years and zooming in just on the high altitude farms so far. So the yellow is going to be sun and green is shade. If we focus on high altitude, we see that in the sun, plants were more variable between years, and that shade helped mitigate it or make it more stable. Right? So this is in agreement with what we found in our manipulative experiment as well. But if we look at the average yield between years, we see that shade also limited the average yield, right? So in this case, it's sort of a trade-off between, okay, do I want a higher yield overall but it's less stable? Or do I want slightly lower yields that are more stable, right? So that sort of is getting into the realm of what are their priorities and what are their preferences, right? Okay, what if we move down the slope a little bit into the middle altitudes? Now we see really not much of a difference. The sun is sort of a wider range, but basically same variability between 2 years and no effect on yield. So it's a little different from the high altitude. It suggests that farm altitude does have sort of a role here in what's going on. And if we look at the very low farms, we actually see the opposite of what we saw in the high farms. So now in the sun, it's less variable than in the shade, but it's also lower yielding. So in this case, shade will help you have higher yields, but they're going to be more variable with time. So again, that sort of trade-off, and it depends on what the farmer prefers. And so more analyses are to be done with that. We're going to zoom in or look at some other variables there as well. But we're excited about this idea that it seems that farm altitude does tend to mediate the effect of management. And what's extra sort of exciting is that this is an altitudinal gradient that isn't enormous, right? It's not like 1,000 meters to 2,000 meters. It's just this in the range of 500 meters along this slope. We see that the farm elevation really does play sort of a mediating role on the effect of shade. So that deserves further attention, I think. Okay, so as Colin mentioned at the beginning, we're really interested in farmer perspectives. So what do the farmers make of these resource trade-offs? Do they perceive them? And how do they compare to our experimental findings? So I'm just going to go through a couple of the questions that we've asked so far to the 30 farmers that we've already interviewed. Special shout out to Ida Weiss, who was our GRAP fellow last year and who was really took the lead on a lot of these interviews and in pulling together this sort of initial analysis. So first, if we look at, does shade influence alternate bearing? As a reminder, we found that yes, shade does tend to promote stability compared to the sun. And that's really in agreement with what most farmers thought as well. So about 90% pointed that yes, shade does influence alternate bearing. So great. But when we look at the effect on quality, so does quality differ with quantity? Most farmers said no, but we found, so the stars indicate what we found. And so we found that yes, quality is impacted by quantity or alternate bearing, whereas farmers disagree. So this seems like an opportunity for enhanced knowledge transfer, where we talk more about how quality is related not only to things like cultivar, so there's different sort of variations of the arabica that a lot of farmers pointed to as the driving factor of quality, or even altitude, but very few thought that there was a relationship with quantity, and now we know that there is. What about the effect of altitude on alternate bearing? Pretty divided here among the farmers, so about 2/3 thought there was no effect, and 1/3 thought that there was an effect. And we have found so far that yes, it does seem that altitude plays a role, not only in alternate bearing, but also on the mitigative effect of shade. So we're excited to dive in a little bit more. So again, this is another opportunity where we can look to enhance the knowledge transfer between scientific and the farming communities. Okay, but how do we do that? So we asked how farmers developed sort of new approaches and techniques. And the majority of farmers pointed to sort of this, what's called lateral transfer, or with peers, neighbors, friends. And a majority, but not everybody, also talked to the agronomist. So that's sort of a form of perhaps vertical transfer. So the agronomists are considered sort of experts, and many people rely on them to get new data or new information and ideas as well. An interesting little tidbit about that is that it seems like the smaller scale farmers are the ones that don't talk much to agronomists. So I think that's an area that could be explored further. It could be a matter of agronomists sort of, it's maybe not worth the time of the co-op to spend a lot of time training the smaller scale farmers or what's going on there. But it seems like the smaller scale farmers, since they're vulnerable and everything, would be a great opportunity to sort of do a deep dive into where they are accessing new knowledge as well. okay, so if it's peers and agronomists that share the information, then where do we come in and play and sort of share what we've found so far? In our strategy so far, we developed these summary sheets. Like this was the most recent one, so it's in Spanish language, and we just sort of update them on what we found with the analyses since the last time that we've seen them. So we'll go probably about twice a year, we give them these sheets. And the Lunch and Learn series is no stranger to the fact that pizza is a great way to share knowledge. So we give them coupons, and just as a token of our continued appreciation, but also as sort of an incentive to feel invested and valued by this project, invested in the project and valued by it. And we're really excited to, at the conclusion of the study, to go down and do a seminar with the help of the local co-op, where we share sort of our cumulative findings overall. So if we tie everything together that I've talked about today, we found that resource trade-offs do play a role in coffee's alternate bearing. Nitrogen looks like a candidate resource that's depleted through fruiting. Fertilizer and shade management have the potential to affect alternate bearing, but the effective strategies are going to differ by farm altitude. And the relationship between quantity and quality, as well as the effective altitude, are some great opportunities to enhance knowledge transfer. And so our next steps, we're going to look at how nitrogen stores, like I said, like when do they recover, or when do we see that sort of difference disappear, if ever? And we're going to look at synchrony among plants. How does that differ across farms? And we're going to expand our farmer interviews to get a broader understanding of how they're sort of dealing with these, perceiving and understanding and grappling with these resource dynamics as well. With that, I will thank plenty of people. This work couldn't be possible without many, many field assistants. My advisors, Colin Oriens, Laura Kuhl, Elizabeth Crone, Michael Reed, and George Elmore are also advisors on this project. Of course, the farmers for lending me space on their farm and their time and their knowledge. They've been incredibly generous with us. The broader lab group of the Oriens and Crone, and lots of organizations, so the local co-op and eCafe have helped us a lot, and it wouldn't be possible without lots and lots of funding to help us get down there over and over again. So with that, I would love to take any questions.
Thank you, Gabriela. A big round of applause. Thumbs up reaction. Thank you very much. We have time for questions. If people would like to ask questions, again, if you could do the participants, and if you could then raise your hand, then Gabriela could call on you to answer any questions that you might have. And at this point, maybe we should stop sharing the screen so that and we could just see each other in sort of
I'd like to say, if people don't know how to raise their hands using that option, they can also just maybe type that they have a question and we can unmute them. I have a question while people figure out how to find their raising hand. Actually, I have a couple of questions. Okay. So first of all, thank you so much for a very clear presentation and very interesting results. So as a plant ecologist, of course, I'm thinking about pests and insects. Yeah. And you talked about trade-offs, talk about nitrogen, how there's a trade-off in the quantity of nitrogen if there is more or less fruits. You also talk about trade-offs between years. So of course, my thoughts were going towards, so what happens in between bearing years? So presumably they are not using so much nitrogen to produce fruits between years. So does that make them more resistant to pests because they are allocating that nitrogen to defense compounds? And also along those lines, do you see any trade-offs in defense within bearing years?
Yeah, thank you. So that's a great question, looking at sort of how does this all interact with disease and pest attacks. And Madeline Bondi has been doing her senior thesis with us this year, and her whole focus has been looking at this branch dieback. And so that can be either fungal, the anthracnose fungus attacks the branches and causes not just the vegetative tissue, but also it's really devastating. It dries up the berries and cherries and everything. And what she's found so far is that she didn't find as strong of a relationship with fruit load as we thought. So we expected those with more fruits to be more vulnerable. And that's somewhat true, but what really had a really significant effect was the number of leaves. So it seems like if they're able to sort of have the resources to have sort of general health and plant vigor, then they're better off against that fungus at least. And we do have lots of data on diseased leaves with there's ojo de gallo is the Spanish name, or chicken's eye fungus, and the rust fungus, but I haven't dived much into it yet though what I have seen is that the shade tends to actually mitigate disease. And that's another opportunity where farmers tend to point to increased pests under shade cover as like a barrier to adopting shade. But so far in all of our studies, we found that in the shade, there was actually less disease or fungal pest incidents than in the sun. So that's something, now that I can't be in Costa Rica, maybe I can dive more into that data.
Yeah, I'd be curious also with insects. My second question is, I hope I can do a quick second question.
Sure.
Is that you mentioned a lot of undergrads as you were showing your data. So yeah. I was wondering if you could talk about any opportunities for undergrads or maybe even graduate students watching right now and how to get involved in your project.
Yeah, thanks.
Possible.
Yeah. So our March trip, we tried to go down during flowering. That was canceled for COVID reasons. We'll see about the summer, but yeah, certainly I've been going down 3 times a year, and I've brought a student on basically, at least one student on basically every trip. And we work really hard to get funding so that it's at the very least free and often paid opportunities. So I don't know of any specific one sort of lingering right now. We had the GRAP, the Global Research Assistant Program, applications were due a couple months ago. So we have some students lined up for that for over the summer. It's looking like more of a remote opportunity, but we'll be taking a trip probably over in December. That will likely be my last trip, but Colin and other people are going, or a data collection trip. But the project is really taking off now, and we have a new student coming in, and she'll be making lots of trips. So I think just keep your eyes peeled. You know, Sarah, Coco, you're always the first to know of upcoming opportunities. So if you haven't signed up for that newsletter, any undergrads out there, you better. That's where you get the Costa Rica fun times.
I will put the link in the chat box.
Yeah.
Thank you, Gabriela.
Yeah, of course.
So I see a question from Roman.
Hey, brother. You're muted.
Oh, sorry. Go ahead.
Hi. Thanks again, Gabriela. Very intriguing presentation. I really enjoyed it. I had maybe a question. I'm not an expert on any of this, but I wanted to know, it seems that when I go to, Starbucks, Dunkin' Donuts, right, they seem to be steadily increasing their prices by 5, 10, 15 cents. But do these alternate bearings, these huge variations in coffee prices that it's costing the farmers to produce, the money that they're getting obviously has kind of a bigger effect with the amount that they're able to put into new coffee farms, how cheaply they can grow it, right? How much they have to reinvest in the industry. So I was wondering, do those huge variations, do you think that they play a role kind of in the bigger coffee picture, like the average coffee unit price or whatever?
Yeah, that's a great question. Thank you, Roman. So certainly when they synchronize up at a large scale, so I showed in the beginning that graph of a low year in Brazil affecting global coffee prices for everybody else, right? so that's one way in which, yes, it can have a huge impact. But I think what's interesting is that a lot of the countries like Costa Rica, basically all of the Latin American countries that produce it, with the exception of maybe Colombia and Brazil, they're really a high quality market. And so they're really like, what good is it to have a huge quantity if it's not also high quality? And I think that's been becoming clearer. And that's why there's been sort of a return to the shade coffee to really put the emphasis of how do we produce the largest numbers we can without compromising the quality. So it seems like something that still sort of grappling with and trying to come to terms with. And I'm not sure if this is maybe tangentially related to your question, but there's also a lot of, you'll see at Starbucks or Pete's or whatever, lots of certifications as well. And I think those are a great opportunity to incentivize farmers that are reluctant to put in these. So one way to sort of incentivize more biodiverse and resilient farms is through certifications, right? And the idea is that those will compensate any perceived losses or realized losses in yield or anything like that. So I think that's an opportunity, but they definitely there's no sort of perfect certification out there yet. And I think more work needs to be done both on sort of what are the effects of the certification on the plant level, but also how do we effectively get that money to trickle down to the farmer in a meaningful way.
Thank you. Thank you.
Thanks.
Gabriela, I can't raise my hand because I'm a host, so I'm just going to ask my question.
Sure.
So you've highlighted that, you know, they've got diseases that cause, like the rust will cause them to lose their leaves. Your suggestion is that the number of leaves on a shoot are like super important in terms of thinking about the branch dieback. And then you also pointed out that the nitrogen levels in the leaves might be really important. Do farmers ever do foliar nitrogen, like fertilize by spraying nitrogen on the leaves as opposed to applying it to the soil? Is that a mechanism that you could keep the leaves healthy without having to like maybe apply quite as much that might get leached out of the soil?
Yeah, great question. So certainly some farmers do use foliar nitrogen, and we have that data in our interviews. We've asked them. So seems like one opportunity, but also it seems like probably it's the wealthier farmers that tend to do that, or those that rely heavily on coffee rather than having alternative incomes. Those are the ones that most invest in any sort of all of their products. But it would be interesting to look at sort of a more specific plant defense role and how that plays into the trade-offs, whether it's related to bean quality, to fungal defenses, and among other things.
Mm-hmm. Thank you. Any other questions? Yeah. You're muted.
If nobody has other question, I do have another question. This is such cool work. So you mentioned that most people rely on their neighbors and friends. There are also a lot of people relying on agronomists, and then you show interesting data that was where the perceptions by the farmers were contradicting with the things you actually saw in the field. Mm-hmm. My question is, what do you think is the farmer attitude towards accepting a different reality? So this is what they're seeing in the field, but then somebody from the outside is coming and telling them, no, you're actually wrong. So can you talk a little bit about how to bridge that gap? Yeah. And what kind of trust is there between the farmers and, in this case, I don't know if you put the academics with the agronomist. I don't know, just can you talk a little bit about the relationship?
Yeah, that's a really great question. I think sort of a flaw of much of the literature or research that's been done is to, particularly in these like technological interventions, you think you've solved it, right? And then problem solved. But if you don't consider what drives the decision making to actually adopt that intervention, then you've largely failed. So that's what we're trying to integrate with the interviews and understand, okay, so if we observe this effect of shade, why don't people use shade? And so we've asked them about what are sort of the obstacles or barriers there. And a lot of people have pointed to a perceived increase in pest pressure. So we were trying to get at that as well and be like, well, that's maybe not entirely true, but also labor costs. So you have to pay people to maintain the shade. It's a liability if the people with the machetes that are trimming the shade injure themselves. And so those are insights that benefit sort of the scientific community, and also hopefully the certifications to take into account, okay, so if we want people to use shade, not only have we seen that it benefits X, Y, and Z, but we should also offset the cost of this labor or potential liabilities of maintaining the shade. So I think that's sort of one way, is to get a thorough understanding of what drives their decision making. Whether or not people will sort of believe my results, I'm not entirely sure. I think there's a little bit higher trust than some previous researchers that tend to be associated with the chemical companies. So they will come and perform an experiment on the farmer's farm and then leave without ever sharing the results. And that's happened countless times, even with Miguel, who I showed at the beginning. And so we've worked really hard to make sure that that's not what we do, right? So we keep them up to date on everything that we found so far. They've been really critical in helping me understand the data. I was like, wow, I was really surprised that the shade ones actually produced more fruits. And they're like, oh, well, that's probably because this was a really dry summer. And so if you were in the sun, you didn't have the root capacity or soil capacity to retain any moisture, and you were in really bad shape. So I think there's opportunities not just for us to think about, or us being researchers or academia, to think of how we can communicate to them our truth, but also to understand how we can integrate their insights and their truth into our broader understanding. So I'm excited to embark on that part as we sort of conclude and try to weave it all together. And hopefully, if at least sort of one or two farmers grab onto this, and then they are now the peers, right? So then they can sort of share it more laterally. If we can just get a couple seeds in there to help spread the word.
Awesome, thank you.
Thank you.
Well, I think we should probably end there, but I just wanted to thank you for your sort of introducing us to sort of both the world of coffee, but the world of coffee people. I think your perspective is just really valuable for anybody who's thinking about working in systems where people are really part of it. So thank you for sharing your insights and your data with us. And looking forward to see you. And another clap, or virtual or real. Thank you so much. And everybody stay healthy and safe, and we'll see you next week.
And can I add something?
Please.
So if you would like to keep talking to Gabriela, we're gonna leave this room open. I'm just going to create a breakout room for the 9 students that are taking it for credit. So feel free to hang out as long as you want and talk to her or each other. Bye, everybody.
So if anybody wants to stick around, ask a very specific question, like how do I work with you? Or some data? I'd love analyzing data. I'd love to do some data analysis. It'd be great to have. Feel free to jump in and ask Gabriela any questions you have.
Maybe even do an art project.
That's right.
That's right.
Interpretive dance. We don't have that one yet.